Cool. So start with a quick poll. Put your hand up if you run a service mesh. And keep your hand up if you build your own service mesh. Not many people. Liz, you don't count. Cool. Today I'm going to convince you why you should build your own service mesh. No, I'm just kidding. I think it's a very niche technical choice. And you should probably be using another service mesh. But I thought it would be really interesting to talk about our experience at Monzo building and operating our own service mesh. I think it's really interesting to look back at some of the historical decisions, the constraints, and some of the requirements we had. And I think there's some interesting sort of learnings and takeaways from that. So first of all, who am I? I'm Miles. I'm the tech lead on our infrastructure platform team at Monzo. I really should have put that I work at Monzo on the slides because I don't know if you've been able to tell otherwise. But I've been at Monzo for 5.5 years, working on various different bits of our platform, mainly interested in where we run services, i.e. Kubernetes, and the networking and service mesh communication bits that allow services to communicate. And if you haven't heard of Monzo, we want to make money work for everyone. We're a digital bank in the UK with millions of customers, offering savings, loans, advanced money management features, and some strikingly coloured cards. And something cool we launched recently was an investment pot. Go check that out. But rewinding the clock a bit, all the way back to 2015, this is something like what our app looked like. And it was pretty straightforward. You could spend some money on your card, send money to friends. You could see where your money was going and your spending trends. And don't get me wrong, there's a lot of complexity that this screenshot doesn't really kind of do justice, but it was a fairly simple product. And our architecture was also pretty straightforward. But unlike many other startups, we decided to build with microservices right from the start. And this is because we had ambitions to be a lot more than just the simple app that we see here. And banks and fintechs are fundamentally a far more complicated product than just spending money and sending money. And over time, we just added a ton of features we knew would extend the system and grow our engineering team. So we decided to use microservices. And microservices have a lot of advantages, but they also have some challenges that you need to work with. For example, you're basically creating a large distributed system, and instead of communication between different parts of that system, maybe going over memory in a function call, you're now making that go over the network. And one of the first things that many people learn when they are working with distributed systems is that you can't trust the network. And the network is, you have to treat the network as fundamentally unreliable. And operating microservices forces us to deal with failure upfront. And there are many ways that you can deal with this failure. You can add timeouts to make your system fail fast. You can retry requests automatically to work around transient network failures. But you also don't want to retry too much, because if you overload the thing that is already down, then you'll make things work. So we want things like circuit breakers as well. And there are also other problems that we need to solve with distributed systems. Like service discovery, you probably need something a bit more advanced than DNS. Observability, you really need to know what each part of your system is doing, particularly for debugging failures. And ideally, you would build these at the platform level, rather than having everyone just kind of write their own thing in microservices. Going back to 2015, this was something that people were thinking about and starting to kind of work with. And we had these client libraries like Hystrix and Finagle. And these were JVM libraries. You could pull these into your application. They would handle reliably making requests for you, observability, a lot of the things that I just mentioned. But libraries are pretty painful when you have a lot of microservices. You need to keep them up to date. If there's a security patch, you need to go and roll them out to all of your services. So what if these features were just part of the platform itself rather than the application? So Monzo in 2015 went down a slightly different path than what you'd expect. For what I'd call our first service mesh, we use RabbitMQ. And for those of you who haven't worked with RabbitMQ, it's a message queue that uses AMQP protocol. And like many message queues, you can create topics, you can publish messages to those topics, and then consume from them. And AMQP and Rabbit have a special feature, direct reply, which allows a service consuming from RabbitMQ to send a message directly back to the service that originally published that. And we felt this would make a nice kind of basis for our RPC system. So we have service A, which wants to make a request to service B. It publishes to Rabbit. Service B consumes that, does something with the request, and replies directly back to the original workload. And this might sound a bit weird, but it solved a number of the problems that I just mentioned. Service discovery, you only need to know where the RabbitMQ brokers were, and so you could just publish or consume. Queues are also naturally very good at handling retries. So if you can't process a message, you can just put it back onto the queue and try again. And also has some really nice properties in terms of scaling. The service that's receiving the messages is basically in control of how many messages it's processing. But it wasn't all great. RabbitMQ, for anyone who's worked with it, will know that it's pretty finicky to operate, particularly in a Kubernetes environment that it wasn't really designed for. And good luck debugging it if you don't know Erlang. And there are also kind of limited options for extending the capabilities of RabbitMQ and making it more complex. For example, adding advanced routing, doing things like canarying, and even things like observability. But ultimately, it wasn't just about RabbitMQ itself or the specific technology. Trying to do synchronous communication, which we wanted to do with RPC requests over an asynchronous message queue model, was always going to be pretty difficult and challenging to kind of get our heads around. So luckily, at the time that we were starting to really feel some pain points with RabbitMQ, there was a cool project called Linkerd, which came along. And this basically took the finagle library that we were just talking about and wrapped it into a nice, neat sidecar proxy and added some features. And we decided to move to this, and it was a pretty simple setup. We'd run a Linkerd proxy per Kubernetes worker node. All the pods running on that node would share that individual proxy, and we configure that proxy to route requests to the correct service. And for service discovery, Linkerd has its own component called named, which interacts with the Kubernetes API and provides the information. And this worked really, really well. It wasn't all plain sailing. If you've not seen this Kubernetes keynote, KubeCon keynote, I would really encourage you to watch it. It's one of my favorite technical talks. I just don't have time to recap it here, but we did an etcd upgrade and had a very nasty interaction between etcd, which took down our entire service mesh. And it wasn't necessarily Linked's fault, although a bug in Linkerd was one of the factors, but it's an example of how kind of critical the service mesh was for us. Then I joined Monzo in 2018, and this was on my 4th day. I was simply trying to scrape some metrics from Linkerd, and I configured Prometheus to scrape it, and caused some issues with card transactions, so that was fun. Now, I'm not saying this to just kind of throw shade on Linkerd. I think it was a fantastic piece of tech for the time. It really helped us kind of grow from where we were. But we were definitely starting to feel some growing pains. Like, you shouldn't see impact on actual kind of live services just by kind of scraping metrics. And there was something else exciting coming up in 2018, which was crowdfunding. And we basically told all of our customers to go and open the Monzo app at a specific time of day and invest in us. And this is really, really cool from a kind of marketing and community engagement perspective. It was like a mega exciting thing to kind of be part of. But from a platform perspective, absolutely terrifying. Like, we basically scheduled a DDoS attack on ourselves. Like, you know, why are we doing this? But we really wanted to prepare and make this a success because obviously, like, the Monzo platform falling over because we told everyone to open the app, not really a very good look. And this meant kind of going through and eliminating all of the bottlenecks, or as many bottlenecks as we could find. And one of these was Linkerd 1, and it just wasn't kind of cutting it anymore in terms of the throughput we needed. And this is when we decided to move to Envoy. And you might be wondering why, if we were already using Linkerd 1, why not just go to Linkerd 2, which was just sort of coming out at that time. And the timing didn't really work out here, unfortunately. Like, Linkerd 2 is just slightly too immature, and maybe we'd have been fine with it, being at that level of maturity a couple of years before. But at this point, you really needed something kind of rock solid and battle tested. So we chose Envoy. And this is what our architecture looked like, pretty similar to Linkerd. We'd have a proxy per node, which send a request to Envoy, which would then forward them on. But there's a missing piece of the puzzle here, which is that the Envoy project itself is just provides you a proxy. And you need something else to do the service discovery and configuration parts using this XDS aggregated service discovery protocol. And there is a project that you might have heard of, Istio, that does this. But if Linkerd 2 in 2018, 2019 wasn't mature enough, Istio definitely not. You know, even back then, it was a really kind of powerful piece of software with a ton of features. But we didn't really need 90% of those features at this point. We literally just needed something to read from the Kubernetes API, read a list of services, and turn those into Envoy config. Not much more than that. And this is when we wrote our own, effectively our own service mesh control plane called Envoy case Disco, which I really like the name of. And this was a really simple thing, like no more than 200, 300 lines of code. And this works great. And yeah, this is what the setup looked like. Now, this worked fine for a while. Then some new requirements came in. So up to this point, we'd been doing fine with any service being able to talk to any other service in the cluster. That's fine when you're sort of fledgling startup trying to get traction. But at some point, our security risk appetite just didn't line up with that. And we needed to fix that so that services could talk. Services were restricted in the other services that they could talk to. And we wanted to use Kubernetes network policies for this. Now, there was a key problem here in that we were still using Envoy as a single proxy on a node with several services sharing it. And you can probably see the problem here in that we can't use Kubernetes network policies here because we need to allow all traffic between the envoys and other services. We can't distinguish whether like the Kubernetes network policy can't distinguish whether the traffic is originating from service A or C or D. And we decided to solve this by moving to the sidecar model. Nowadays, of course, there's many other kind of ways of solving this, but this was really the only way we could work out how to kind of control that traffic. But we needed to upgrade our control plane to support this and add and generate a config per sidecar. So we rewrote it, made it a bit more complex, but still not really too complicated to work with. Still quite manageable in terms of code. And you might be starting to wonder at this point, like, why continue building our own service mesh? Like, is this not a good point to go and look at something like Istio or one of the numerous service mesh projects kind of coming out kind of later down the line. And are we not just falling into a kind of sunk cost fallacy by continuing to invest into kind of writing our own service mesh? But I think it's important to remember at this point we were trying to work towards a specific goal, in this case of enabling the network policies, but other features we were building in our service mesh were to enable some other kind of business value. And moving to an entire kind of new service mesh isn't just a case of running Helm install or whatever installation script you have. You might do that with a toy cluster, and that'll work fine. But for a kind of rock solid, like battle tested production setup, there's so much more work. Like we need to go and define all the kind of configuration we need. We need to understand the behavior, like peek under the hood, work out what's going on, look at all the kind of failure modes, and make sure we understand how things work. So when they break, we can fix them. And then from a security perspective as well, we really need to understand what these other service meshes would be doing. We need to be comfortable that the security controls match what we do, match what we want. And all of the time we ultimately spend doing all of that work is ultimately time we're spending away from the primary business value that we're trying to achieve right here, like implementing network policies. Now, since then, we've continued to invest and added a few more things, like mutual TLS authentication, cross-cluster communication, locality-aware routing. So I want to talk a bit about how I think we benefit from building our own service mesh, outside of the kind of context behind why we decided to. And there's this concept of undifferentiated heavy lifting, which quite a sort of popular thing to talk about. It's the idea that you should focus on your core product and your business projects and value, rather than on things that you can pay other people to do. But I think the counterpoint here that we realized much earlier on in the line is that Monzo's platform and microservices is a bit of a superpower that lets our product engineers move really fast. And knowing the technology we run really, really deeply means that we can fix things and make things much more efficient. And because we're working with lower level abstractions, we can customize things to kind of fit what we need very, very tightly. But of course, there are drawbacks. Like every feature that we need is something we have to build ourselves. We don't benefit from the amazing work of the community. Like, if we want something else, we have to write the code for it. And we're also entirely on the hook for fixing everything ourselves. Even if we're using a kind of self-managed open source project, we could go and open a GitHub issue if we're seeing a particular bug. But it's kind of completely on us. Like we are the maintainers. So I guess the key question is really, would we do it again? If we were starting from scratch today, I think there's a pretty simple answer is no. Like why would you just write a service mesh from scratch when you're trying to solve all of these other things? I think nowadays in 2023, there are lots of very mature, very scalable, secure service meshes, and very, very flexible ones that can kind of fit what you need. And not just on a kind of self-managed front, there are lots of smart people around to kind of help you run them for the right price. But I think the historical context here is important. Like we originally built our own service mesh at a time when that wasn't the case. And we've kind of taken that knowledge through with us. And what's in store for the future? Right now, we have made our service mesh across cluster. I'd like to think about how we can use it across regions or perhaps even clouds. I also want to start thinking about how to make it look more of like a standard service mesh. So perhaps implementing standardized specs like Gateway API or even CRDs from other service meshes. And I think that not only eases the potential migration path in future, but it also eases the kind of cognitive overhead of people coming into the team and learning how to use the service mesh. And ultimately, I think there will be an inflection point at some point where the value we get from building features that eventually bring us in line with other service meshes, or like the value will be less than just migrating to another service mesh. And that's everything I had. I won't take questions now, but I'll be around later and all of tomorrow. So please come and grab me. Please, I'd love to chat about service meshes. Thank you.